right now. So here's my main function. I have a by the way, I'm going to have a function called square. It has a variable variable y in it. Here's my function prototype. I'm going to go in my main method. I'm going to make a variable x. I'm going to have a loop that goes from 1 to 10. I should always start at 0. I do not like this loop. And I'm going to print off what the value is each time around. So I call the square function, and this is going to spit out 1, 4, 9, 16, 25, all the way up to 100, which is 10 squared. Okay, so my print statement, I have a print statement that and each time through the loop, that x value goes up by 1, and I just square the x value, and I print it off. I'd like to point out, here's a function inside a function, which is inside a function. This is the f of g of h thing that I was talking about at the very beginning when looking at mathematical functions. We can have functions within functions within functions. The square function is within the printf function, which is in the main function. Okay. So here's my actual function definition for square. It has a variable y. It returns y times y. Great. Okay. I want to point out that let's make a variable, it's not going to change anything at all. I'm going to say that's not going to make any difference at all for a reason. Because when I call, this is what is going to lead us to scope. This y here is different than this y here. And when I talk about y, which y am I referring to? I'm looking at the local variables first, the stuff that I'm around first, before I start looking at global variables. So nothing in my code will have changed. Despite making a new variable called y way up here, this y and this y are different y's. And when I say y right here, which one am I meaning? Well, probably the one that in the function that I'm in. I have a local variable called y in the function that I'm in. That's probably the one I want. So here's actually what happens with, in case you're talking about this, function within function within functions. This is actually what if you've ever gone to the website Stack Overflow, this is what it's referring to, a call stack that overflows if I have too many recursive calls or too many function calls. We won't get into that detail, but what a function call is this? I have my main method. So I call main. I have a bunch of variables in this box, let's say. Okay, I can have as many variables I want in this box. Where am I dealing with? I'm dealing with the main function. That's where I'm pointing at right now. When I call printf, I will put a new function on top of my call stack, and I will be pointing at that function. I will ignore main for the time being. While I'm pointing at printf, I'm only dealing with printf. I'm not dealing with main. I'm going to pretend main doesn't exist. Much like if I put a tray on top of another tray, I don't worry about the tray beneath. The tray on top is the one that's getting dirty. The tray on the top is the one that I'm going to pick up and use. The tray on top is, the tray that everyone's looking at, right? That's what a call stack does. It allows me, every time I make a function within a function call, within a function call, I'm going to put something on top of the call stack. I'm going to do a bunch of actions. I'm going to follow all the instructions in that function, and then I'm going to go back. But wait, printf calls another function. So when square, which is in printf, gets called, what happens? I call square. I do the instructions for square. Then I will get a value. I will then go back down a level, and I'm now pointing at printf again, with a value for square having been resolved. I figured out what square of y is, and I can now deal with everything in printf. When I'm done with printf, it pops back down again, back down to main, and then by the time I'm done with it, the only thing I have left is main. The reason you need to know about this is if I have a variable y here in square, I have a variable y here in printf, and a variable y in main, there's no problem. Which y am I, if I'm in square, which y am I talking about? I'm talking about the y in square. If I'm down one level and I'm talking about y, what am I talking about? I'm talking about the y in printf. There's no collisions, there's no problem with it because I'm only looking at one function at a time. When I call a function, I put it on the call stack and I deal with that function, and then I go back down again later. Like a stack of dishes, right? I deal with a top dish, and then I add more. Then when I add a dish to it, I put it on top of the stack. Okay. So a local variable, this is something like int y that I had in the square function, right? I have a local variable. It's actually a parameter, but it's a local variable. I can make just a variable in my function. It's declared within the function. It exists, it lives and dies within the function. And then when the function ends, it's destroyed. It's given back to the system. It does not exist anywhere beyond that. Okay, so let's see if I can make a nice little function here. Int bad name, variable name foo. Int x. Actually, I think I have one of this. I'm going to have one of these afterwards anyways. I'm going to have another example, but so local variable, that would be this thing here. Parameter is this. It is also just a local variable. The only difference is it gets set. It gets automatically set. When I call foo, that value of x gets set. It's a local variable, but the value for it gets set. A global variable exists outside of all my functions. Every one of my functions has full access to it. It would very much be like you writing your credit card number, though, on the wall outside of the labs. It does not seem like a very good thing. That's what the problem with global variables are. If it's out for anyone to use, anyone and everyone will use it. And so you have no idea who is using it, what they're using it for. So even if it's something like if you just put your credit card number outside, you can expect people to abuse it. That's why global variables are bad. And if you want to see outside, even outside of your one file, if you want to see it in other files, you can use the extern keyword to make it visible to everybody at all times. Now, global constants are fine. You can't change them. So I can make a constant instead of saying just having a variable, const int my value is equal to 4. That value is never going to change. No one else can change it. So it just means everyone's looking at the same number. That's fine. You don't have this weird case of, oh, somebody else might use it and abuse it. If I have a variable, I expect other functions could change it on me. And that makes it really hard to program. All right. So just letting you know, when we're talking about scope, we're not talking about that kind of scope. We're more talking about this kind of scope. Now, it's a bit dark for a gun scope, but same with a microscope or a telescope. What is a scope? It is something that limits your view or defines the view in which you see something. So a microscope limits your view to a very, 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 very small area of like a petri of a little dish or a slide, so that you can see, like a yeast cell, for example. A telescope lets you see further, but the scope is way out in the cosmos, but it's a limited amount at a time, right? It tells you the range in which you can see things. Same thing with a variable. The scope of the variable. Everybody can see this variable x, this global variable x. Everyone in the file, the scope of that variable is the entire file. It has a global scope. It's the scope is the file. Here is my main function. It's going to make a brand new variable. It's a local variable. That local variable is limited. This lives and dies between here, this curly brace, and what should be curly brace down here. Missing a curly brace, right? This x here, as soon as I get to this curly brace, it dies. It gets given back to the system. This variable x right here is not in collision with this. Here's an x, here's an x. This variable's scope is between this curly brace and this curly brace. It lives and dies within that limited space. And that's actually an interesting thing to get your head around. That you can have two variables with the exact same name in the same function as long as they have different scopes. Because it resolves which one goes first, which one you refer to first. So in this case, what am I going to do? I'm going to local x in the outer scope is 5. Then the value is 7, and then it says local x in the inner scope is 7. It's what gets, I'm going to use the value 7 here, not 5, because this is in the smallest or the closest scope that I have. This x lives and dies between here and here. And this one out here is the third priority. If there's nothing else named x, it would print off the value 1. But there are 2 other variables named x with a smaller scope. And we're in that scope. So when this is what my metaphor with the screw or the bolt is broken, right? What bolt am I talking about? The one I'm looking at right now. If I'm looking at the engine, that's where the bolt is, right? If I'm talking about x, where am I looking right now? Well, I'm in here. If I talk about x, I meant this x right here. It's the one where I'm currently looking. And if there's no x in here, then I look for an x in here. And if there's no x in here, then I go one level above and look at the x is equal to 1. So in general, if you want to have an idea of where the scope of something is, it's between the curly braces. If I make a new variable between a curly brace and between 2 curly braces, it lives and dies in those curly braces. As soon as I start the curly brace, the opening of the curly brace, I will make all my variables. And as soon as I close my curly brace, every one of those variables gets destroyed. That's the one way to think about it. So I can have curly brace within curly braces within curly braces, and where my variables live and die are based on that, where the matching curly brace was. So if we go back again one more, this variable lives and dies between here and this curly brace here. Not this one here. It's this one only lives within this part. So the associated opening curly brace and the associated closing curly brace is where this x lives.